This video is over topic 2 practice questions, looking at scientific notation. So practice number 1, we're just replacing the number name with the appropriate power of 10. So let's just write these out. So you have the first comma level is thousands. So that would be 1000, which would be 10 to the third power. The next level, million. It's 3 more zeros, it's 3 higher, 10 to the 6th. Billion is 10 to the 9th. And trillion is 10 to the 12th. So 21.5 million could be written instead as 21.5 times 10 to the 6th. 8 trillion would be 8 times 10 to the 12th. And 0.834 thousand would be 0.834 times 10 to the third power. Although these all look similar to scientific notation, this first one is not scientific notation because the number part has 2 digits before the decimal point. And then the C is not scientific notation because the only thing it has before the decimal point is a 0. So this also is not scientific notation. This one, 8 times 10 to the 12th, all good, 1 digit. There doesn't have to be a decimal point. It's unwritten. It doesn't have to be anything after the decimal point, but this one is scientific notation. Going on to the next example, looking at converting from scientific notation to standard form. The power of 10, 2 things to pay attention to. Is it positive or negative? Positive means that we're looking at a very large quantity. We're moving the decimal point to make that number larger. The number in that power is not how many zeros to add, it's how far to move the decimal point. So as I have the 1 as that first digit, that decimal point starting out here actually needs to move 11 places over, but I'm going to fill in the first 2 places with the 8, 7 that are already there. So the digits that are in that number part are all still going to be there exactly as is. And that covers 2 of my places. So I need then the other 9. So 9 zeros. And I can put in my commas then. So my decimal point has moved 11 places. This is 187 billion. Thousand, million, billion there. So that would be the number name format. Then this next one, 3.64 times 10 to the negative 4, that negative power means this is a small quantity. It is going to be the 4th digit after the decimal point is the first non-zero digit. So 1, 2, 3, and then the 4th digit is my 3 here. And then I go ahead and write all of those digits. So the decimal point has moved from it was here, it has moved 4 places. So the power of 10 is always how many places that decimal point moves. And the negative versus positive indicates whether we're talking about this very small quantity versus a large quantity. Then practice number 4, converting to scientific notation. We put the decimal point always after that very first non-zero digit. So this is going to be 1.231. Keep all non-zero digits. And if there's a 0 between non-zero digits, keep that as well. But once it's all zeros, you don't need to write them anymore. But don't do any rounding off of those non-zero digits that are there. This is going to be times 10 to the positive because it's a large quantity here. And I look at how many digits were there after the first one, or how far did the decimal point move from that unwritten decimal point at the end of the number. And that is 7 places. And then this next one, we're looking at the 1, 2, 3, 4, 5, 6th place after the decimal point, or in other words, moving that decimal point 6 places to put it after the first non-zero digit. 3.84 times 10 to the negative 6, because this is that very tiny quantity. So that would be scientific notation there. And then here we have numbers that, again, are that form that looks kind of like scientific notation, but isn't quite. Rather than having to fully rewrite this out, if I wrote this and said, all right, I'm going to put it in standard form, I would need to move that decimal point 16 places, count a whole bunch of zeros, and then recount zeros to put it back into scientific notation. I can shortcut that. So I look at this and say, well, this is too small to actually be a 16th power, because our number part is smaller than that. So as I move the decimal point, and I'm moving the decimal point 2 places to get it in the correct position, then I have to adjust the power of 10 and say this needs to go down by 2, because I'm actually at a smaller number than indicated. So 3.4 times 10 to the 14th as we move that decimal point 2 places and subtract 2 from the power. So the number too small goes with subtracting. Then the next one, 13.4 times 10 to the 12th power. 13.4 is bigger than 10, so we're actually a level above, or a space, a decimal place above the 12th. So as I move this decimal point for this larger number, I'm going to add 1. Because I move the decimal point 1 place, I add 1 to the power of 10. So 1.34 times 10 to the 13th power. This next one, again, it's too small. So we're actually at even smaller than the 10 to the negative third. So too small, I move the decimal point and I subtract from the power of 10. Be careful with subtracting negative numbers. So this is 2.7 as I move that, and then negative 3 minus 1 is actually negative 4. And then 124 times 10 to the negative 12. Again, this number now is too big, so I'm not actually all the way to negative 12. It's a larger number than that. So I move the decimal point from that unwritten position at the end 2 places so that I have 1.24. And this number was too big, so I have to add to the power of 10, add 2, because I moved it 2 places. And again, being careful with the negative, adding and subtracting negatives, this is going to be negative 12 plus 2 is negative 10. So that would be the result there. Then going from this standard number name form to scientific notation, rather than writing it out in standard form in between and having to count all those zeros, we can replace the level name with its corresponding power of 10. So million is 10 to the 6th, and then do that adjustment. This is too big of a number. I move that decimal point 2 places and add 2 to the power of 10. And so that's going to be 2.178 times 10 to the 8th power. And then 0.83 trillion. Trillion is 10 to the 12th. But it's actually less than the trillion, so I'm moving that decimal point 1 place and subtracting 1 from the power of 10. The number was too small, I subtract. So it's 8.3 times 10 to the 11th power. And that's it for this just scientific notation, converting back and forth into the different forms.